In the past, we've looked at a visual representation of how a function works, where the left-hand side is the domain and contains all the inputs of x, and the right-hand side is the range and contains all the outputs of y. What our function f does is take all the elements from the domain and maps them or transforms them to some unique element in the range. But what if I want to go in the reverse direction? Meaning, what if we wanted to map all the elements from the range back to their original form in the domain? Well, then we would have to create another function that has inputs of y and outputs of x. If we can find a function that can undo our function f, then we call this new function its inverse, and we denote it by f to the minus 1. This minus 1 here means inverse, so this sentence reads f inverse. If you look at the picture, you will see that the range of the original function has become the domain of the inverse, and the domain of the original function has become the range of the inverse. In layman's terms, their domain and range have switched. Now there are two schools of thought on notation here. Some types of people use x as the variable for the inverse function, while other better people use y. They're better for using y because it follows the intuition of our illustration. Since we're better people, we will use y as our input. Just know that your homework might ask for x inputs. Last thing we must establish is how to ensure a function is indeed the inverse of another. If some function is truly the inverse of another, then their composition should simplify to just the independent variable. Meaning if you compose f with f inverse, it should equal y, and if you compose f inverse with f, it should equal x. For example, notice how both criteria are satisfied. Since only the first criteria is fulfilled, we say that the square root function is not the inverse of the quadratic function. One way we can tell if a function has no inverse is by inspecting its graph. If you draw a horizontal line and your graph touches it more than once, then it does not have an inverse. In other words, if the graph of a function fails the horizontal line test, then it has no inverse. Last thing I want to say is that the graph of the inverse is the reflection over the y equals x axis. Or in other words, the x and y coordinates switch for each point. Let's do a couple of examples of solving for the inverse function. Right now, our function is in terms of x. To find the inverse function, I need to have my function in terms of y. Use algebra to solve for x. I replace x with the proper notation for the inverse.